So yes, my name's Ruth. This is the part of the talk where people introduce themselves, they tell you what they've done, who they work for, why they should be on stage teaching you or telling you about a certain thing, etc., etc. I'm going to show you. That's the easiest way, because I'm here to talk to you about how to be a Web AV artist. What? Exactly, right? So AV, by the way, stands for audio-visual, and I'll get back to that in a minute. But yeah, I struggle with the practicality of this talk. Like, how many of you are going to go back into your jobs on Monday and just code some AV into your website or your web app, right? So I had a little bit of talk anxiety, and I came across this helpful Venn diagram on Twitter, which is also helpful. And what it is, it's on the left, you've got what people talk about in conference talks, which isn't so helpful. And on the right, you've got what you want to hear in conference talks, which is helpful. So I've taken this quite literally, and I've made myself two lists, okay? So on the left, I've got things that I need to avoid, and on the right, I've got things that I need to include. So on the left, I've got analytics, operational excellence, chat ops, and orchestration. Those are the things that I have to avoid in this talk to make this a useful talk. But I do have to include duct tape, workarounds, bike shedding, and coffee. Right. OK, now my talk anxiety is out of the way. We can begin. By the way, I'm using a Joy-Con. This could break at any time, right? So AV, what is an AV artist? AV stands for audio visualization. Okay, so what we're doing is we're taking audio and we're making visualizations from it. So it's not so much of the creating audio as it is creating visualizations based on the audio that we have. Another name for this is VJ. Whoop, I've got control over my audio, so this is pretty loud. Who remembers this? I was like, I'm going to do that again, because I was like, I've got all the audio all the way through this talk. Please don't turn down the levels. Who remembers this? Oh, my goodness me. It's not working, is it? There is a sound bite for that. I'm going to try it one more time. One more time, audio people, because it's pretty cool.
Winamp. It really whips the llama's ass.
Can we keep the audio levels? Thank you very much. Thank you. Yes, who remembers Winamp? Thank you. Can we keep the audio levels up for the rest of the talk, please? There is audio all the way through this talk. Thank you very much. Winamp, the greatest MP3 player of all time, right? For those of you that don't know Winamp, because I'm of a certain age, it basically just plays MP3 and other audio files. When we used to listen to audio files and not stream them, like we used to own the files, we used to share them via Napster. Right? But this wasn't the best thing about Winamp. No. The best thing about Winamp was this. It had a visualization engine, right? So you could play your music, and you'd whip this up, and all these visuals would go in time to the music. And you'd just sit and watch this for hours. I swear this is probably the most influential thing of any VJ of my generation. So I was thinking a few years ago, I was like, OK, we've got some cool browser APIs now. What if I could do this in a browser? That's a really good idea. I'm going to take you through some ways that I have come to actually be able to do this in a browser. The first thing that we need is audio, right? We have a web audio API, and there's probably, yes, it's my favorite one too. There's sort of four main ways to get audio with the Web Audio API. You can grab it from the DOM. If you've got a video or an audio element in your DOM, you can just grab the audio from that, and you can push it through the API. You can stream it from your device. So if you've got a camera and microphone, you can grab the audio from that, and you can stream it through the API. You can go and get a file. You can go and get a sound file. When you get a sound file, you do have to decode it into the API. You've sort of got to buffer it in, because sound files, by and large, are sort of compressed. And you've got to make the audio API understand the data of the sound file. So we decode it into what we call a buffer, and then we can use that data. You can also create sounds with the Web Audio API. So here I'm using an oscillator to create a sound, which is creating a sound wave. You can also use that buffer that I just mentioned earlier, and you can put your own data into that. So you can create things like white noise quite easily, which is just random numbers. The ones that I'm sort of interested in are either like using a sound file. So this example uses a sound file. And this one's actually just picking up on my mic. So this one is me. It gets really quiet, and then it gets really loud. Yeah. The next thing that we need, now that we've got some sound, is we need to analyze that sound. I wasn't allowed to talk about analytics. It's OK. We've got the whole rest of the talk to go. It's fine. We'll be fine. OK. OK, we need to analyze that sound, because we want to use that data to make our visualizations. That's cool. We can do that with the Web Audio API as well. It has the functionality for you to be able to analyze any sound that is in it, right? What we're doing here is we're creating an analyzer node. A lot of the Web Audio API is sort of based around this idea of nodes. I'm not going to go into too much detail about it now, but if you do want to know more about the Web Audio API, come and talk to me later. I will tell you all about it. Somebody wrote some cool stuff on MDN docs about it, so you can go there. There's some cool demos now, and there's plenty of resources out there, and I can point you in the right direction. What the analyzer node gives us back is an array of data. Now, that data is the frequency amplitudes. I know, right? So basically, it's the low sounds all the way through to the high sounds, and the sort of volume value of all those sounds at any given point. So the first few items in the array are going to be the low sounds, and the last few items in that array are going to be the higher sounds, and the data in that item of the array is just going to be the volume value, right? And then we can use that to make our visualizations. So here, all I've got is a bunch of I elements in the DOM, and I'm just taking those values and changing the height of those I elements based on what I'm getting back from that analysis. I've just gone, yeah, HTML and CSS really simple. It took me about 2 months. So I'm just looping over those elements, and I'm just changing the height of them. Now, this is the sort of crux of everything. Once you've got that analysis going on and you're getting that data, everything becomes a little bit easier, sort of. So I started a whole bunch of experiments. Now, everybody knows when you start a bunch of experiments, you need some inspiration. This was my inspiration for my first bunch of experiments. This is a super cool artist, Bridget Riley. You know she's a super cool artist because it says so on the slide. I saw her at an exhibition, and she basically paints these huge, huge pictures of shapes. And she experiments herself with these shapes. And I just was walking around, and I was like, oh, I've got to try visualizing these. These are really, really good. So this is the first one. This is just a whole bunch of sections. And they're all kind of long, just set out with Flexbox. And I'm just changing the width of them based on the data that I'm getting back. This one is that triangle CSS border hack that you've seen. And I'm just changing the opacity of them, again, based on that sort of numbers that I'm getting back from the analysis data. When you start experimenting, it gives you a good opportunity to try new things. This is a couple of years ago, and I was sort of thinking, well, how else can we expand this? One of the things that I really wanted to try was some transforms and get familiar with those. And I thought, wouldn't it be nice if you could take whatever you have in the DOM, because I'm still working with just DOM elements, and sort of copy it and rotate and reflect it around the rest of the DOM. So you shrink it down, and you just copy it around like this, right? So this is only one square, and I'm just running a little JavaScript function to copy that, and then I'm just reflecting and rotating it around. And I thought, hey, this is just stuff in the DOM. So, I mean, this is like a bunch of elements, but you can drop anything into the DOM. Maybe I could just drop an animated GIF into the DOM. Yeah, you could do that too. My Little Pony GIFs, yeah. And we've got some cool like visualizations. Some other lovely CSS things, because I've come to a JavaScript conference, so I thought I'd talk about CSS, that I wanted to try was blend modes and filters. So blend modes, if you're unsure, are just you can sort of see through like elements underneath in different ways. You can darken, you can lighten them. And filters, which will become more apparent a bit later. So you can invert stuff, you can turn things grayscale, you can blur them, all really cool visual things in browser. This was a visualization I did for JSConf EU, and by this point I'm starting to move over to SVGs. So these are all SVG shapes, and you can put blend modes on SVGs, and I'm just putting like a lightening mode on these because it becomes just a little bit brighter and it just gives it a little bit more depth. One more sort of CSS thing, custom properties. I'm sure we've probably all seen them. We probably are all using them now. This is the idea of sort of variables in CSS, right? So you declare the variable that you want to use, your custom property. You do that in a DOM element further up the tree. So we've got a dash level. So as long as you start it with dash, you can call it whatever you want. I've got a level here. I'm setting it to a default value. And then I'm using that value under the properties width and height later on in my CSS. Now, the thing about custom properties, the really good thing, which I was enjoying, is you can update them in real time, right? They're not set at runtime. You can just update them in the browser and they will update. And you can do this with JavaScript. So in my JavaScript, I can take that analysis value and pipe it straight into that custom property, and it'll update my CSS for me in real time. That's JavaScript all up in your CSS. So here, I've got like document element style set property, and I'm setting dash level with that analysis level that I'm getting back. So this is an example of me doing all of those things. We've got some DOM elements, they're being rotated and reflected. We've got some blend modes going on. I'm doing some custom properties. And as you can see, it's a little bit janky. It kind of doesn't like operating very well. You're not allowed to talk about operational excellence. It's okay, 2 down. This can still go either way. So thinking about the performance of all of this, and this is my friend Ben. If you don't take anything else away from this talk, because I am talking about making crazy visualizations in the browser, talk to your friends about things, and not just for rubber duckying bugs, but at your actual project, because they might have some other better ideas. So I was chatting to Ben. You're not allowed to talk about chat ops. Oh my goodness me, that was like 2 in like 2 minutes. Oh, orchestration, that's the only one. I'll make it a useful talk, I promise. So I was talking to Ben. We were doing, this has sort of gone into the realm of doing something quite interactive with it. And he made the good point. He was sort of saying, well, you're doing a lot of stuff with SVGs. You're doing a lot of stuff with data. You're working with the DOM. You're kind of doing a lot of maths. Have you thought about using D3? Now, D3.js being the data visualization library, which back then I was thinking, yeah, this is sort of pie charts. I'm not sure. Some people have done some incredible stuff with D3 since. But yeah, he had a point. I'm doing lots of stuff with data. The analysis that I'm getting back from the audio is data. I'm doing a lot of work with the DOM, and it's pretty good at that. It's pretty good at DOM hopping. I'm doing a lot of maths, actually, a lot of the positioning things and working things around. And there's some really nice features of D3 which deal with maths pretty well. And I just started working with SVGs, and by default, that's how D3 works. So thus begins my next set of experiments. This is a book by Tim Leon called Super Graphic. It charts data from comics and graphic novels. If you like comics and graphic novels, I highly recommend it. It's really beautiful just to flick through. And so I was flicking through this, and I was like, maybe I should try and visualize some of these. This looks really cool. This is your basic sunburst chart. So again, this is all picking up on my mic, so this is just me speaking and sort of moving around as I'm talking. And I starting to get a bit mental with these ones. This is a really cool little rainbow going on. I like this one. This looks good in a club. This one reimagines the spectrum from earlier. So instead of doing lines, I'm now doing circles. And they're just going diagonally across the screen. And this one, which is a little personal favorite because it's kind of small and sweet, it's very similar to the last one. You've just got a little flower, which is just going around. All pretty, I was going to say easy. Nothing's easy. But when you're using D3, you're just sort of copying, and it is making things a little bit easier. What D3 does is it takes each item in the array and creates a shape like an SVG shape per item. You get to define that, which is kind of what I was doing with the DOM. It was just I was doing a little bit more work to do it. One of the problems with this wasn't D3 and what D3 was doing. It was the data that I was getting back from the Web Audio API. I think the data could have been better. Now, this is going to get a little bit hard to explain, but I'm going to try it anyway. These frequency values, these sounds from low to high, they run from 0 hertz, very low, to 20,000 hertz, very high, right? This is what the human ear hears. I'm a little bit old, I probably don't hear 20,000 hertz now, but that's the data that we get back. So that's split up with however many items that you want to put in that array, and you get to define that. But one of the issues that we have with that is music doesn't run that high. Music, this is a musical keyboard, it probably sits around here on that scale, probably goes around up to around 8,000 kilohertz. So when you're listening to music and you're analysing music, there's a whole bunch of items up in this top end of the array that you just don't need. The other problem when you're analysing audio, like music audio, is this. We've got 3 notes on this musical keyboard here. They're actually all the same note in musical terms. They're all A, but they are all an octave apart. So they're all 8 notes, 12 semitones apart, equal spaces apart. And when you play them together, they're very, very harmonious. That's why they all have the same letter. But some are low, we've got a mid one, and we've got a high one. Now, they're equal spaces on the keyboard, but that middle key there, the orange one, if you can see the orange, that middle key I've highlighted, that's a middle A. That runs at 440 hertz. The one below it, the one that's highlighted below it, the purple one, 220 hertz. That's a gap of 220, if I can still do maths on a Friday. The one above it runs at 880 hertz. That's a gap of 440. You see what happened? The gap's doubled. So even though the amount of keys hasn't doubled, the amount of frequency hertz has doubled. So this is a problem because the analysis that we get back from the array from Web Audio is linear. And musical notes don't really work in linear. So I thought it would be really nice if we had better analysis of the Web Audio API. So I chopped off the top of the array. That was pretty simple. And then I spread the rest of the data out. Yeah, magic function. It took me about 6 months. I haven't actually looked at this for about a year, because I just wrote it and I left it, and it was working. I was like, this is great. And weirdly, I was sort of looking at it today, and I was just randomly doing some stuff with WebGL recently. I've been doing some shader stuff. And I'm pretty sure that there's some algorithms that I'm doing with that would actually make this better. So there is a version of this online that you can go and have a look at, but I'm hoping that I can refactor it to be even better soon. So that's what this is doing. And just to prove that it actually works, this is before. Right. So we've got, on the right there is where the shapes start. So this is the lower end of that array. And you can see that it's bigger. And then this is after I run the function. So everything's just spread out a little bit more. And we've just got a better amount of data. What about Canvas? So at the moment, I'm still using like SVGs, and it's still kind of a little bit heavy, if I'm honest. And when I started putting more items into that array and started chucking more shapes into the DOM, I did start to see a lot more performance problems. D3 really wasn't necessarily the answer. So then I started to work on 2D Canvas, which is the one that you saw at the top of the talk. And this is a lot cleaner. It does, like, it's kind of running, because I'm running so many things on my laptop right now. But when you run this alone, this does work better, and I can just chuck so many shapes, and it's brilliant. If you want to see all of these, they are on CodePen. Most of my CodePen is audio visualization, so you can see that journey from when we sort of begin from not being able to do very much all the way up and doing some Canvas visualizations, if you're interested. One last bit. We've got time? Yeah, I've got time. This is great. We've got some visualizations, but to really be able to sort of VJ to a band or like to a DJ in a club, which that would be cool, right? I need to be able to control these. Now I can probably control them using the keyboard on my laptop. There are some other APIs which are fun, like Gamepad API is pretty fun, but I find it's a little flaky. I'm really glad this is holding out. It's still holding out, it's great. Web MIDI API, right? We actually are able to run MIDI in a browser. Just a little bit about MIDI, just a little rundown. It's not those bleepy noises that you hear. right? It is a data protocol so that instruments can talk to each other. It came about because of the rise of popularity of electronic instruments in the 70s. So in 1983, a group of industry experts, electronic music manufacturers got together, and they put together a specification, an open specification. They're pretty cool. So that all these sort of electronic instruments could sort of pass out data and they'll be able to listen to each other. This is a MIDI-enabled instrument. This is the musical keyboard we saw earlier. I'm probably sure you've all seen one. You've probably seen a piano. It's very, very similar. The thing about this is it's an instrument because it has onboard audio. So when you play it, you are listening to sounds. But it's also MIDI-enabled, so it is passing out those data messages so that it can orchestrate with other instruments. How could I do a talk about audio without talking about orchestration? It's okay. I'm hoping that at least at some point in this talk, you would have got something useful out of it. Never mind. So this is what an instrument is. When we talk about musical MIDI instruments, we're talking about things with onboard audio on. And there's lots of these out there. This is a MIDI controller. It's very similar. You plug it into your computer. You can pick up on MIDI data that it's sending, but it doesn't have any onboard audio. This is what I have with me today. It's actually one of these. It's what we call a launch pad. Great, cool. So basically, I can press button. Well, I can run this code. So what you do in a browser is you request access to these MIDI devices. There's lots and lots of MIDI controllers out there, by the way, if you want to get started. Just Google MIDI controllers. Some of them are really, really affordable, around sort of $30, I think, if I'm doing dollars. And you just plug it in, and you request access to it, and then you can just listen for its events. And all you're getting back is some data, which you can then hook into, and you can do some stuff with. So hopefully, if this is working, yes, this is working. I'm pressing buttons on this controller. This is the data that you get back. It's just some numbers, and you can listen for those numbers. What they sort of mean is, I am this MIDI controller, you're pressing this button, and for those, there are some where you can press it harder and you get different values. You don't on this one, but, just pressing buttons and I'm getting numbers. So this means that I'm going to go flashing now, so be aware this is going to get flashy. This means that I can sort of easily add effects to these visuals, so we can go black and white, we can change the colors, we can go blurry, I can do some inverting, which is my favorite. But also it means that in the actual thing that I use, I can change what it is that I'm showing on screen. I can actually mix two visuals together with you get CCs, which are like dials, so you can actually mix things together in a browser. Is any of this real? What am I doing? Analyzing audio, making crazy visualizations, and plugging in boxes of buttons. This is me with a portable VJ pack. I took a handbag. I put my laptop in, I've got a mini projector, I took one of my MIDI controllers, and I kind of hacked the handbag. So you can actually unzip it in a certain way, and it acts as an usherette tray. And you can just plug the little projector in the bottom, and you can just walk around projecting onto stuff, which is what I did. This is me doing it in my streets of my city back in the UK. I wrote a blog post about this, and someone on the internet's found the blog post, because the internets are cool. And they said, hey, I'm doing this too. And I was like, what are you doing? And actually, there's a whole group of us doing it. We're called Live.js. We don't just do visuals. There's a couple of people out there that make software that plays music with JavaScript. There's a couple of people out there that actually control whole lighting rigs with software that they built in JavaScript. If you want to check us out, we're on livejs.network. We play gigs, which is slightly insane, I think. But it works, and we do it, and it is great fun. And we talk to each other about all the crazy technology that we use, and they're great people to talk to. And we also have a GitHub repo, so as far as I'm concerned, that must be real. Is this the end of the story? This was a couple of years ago. Since then, performance still was an issue. When you've got two canvases running because you're mixing with them, you've got all these shapes going on, you're analyzing that audio as well. I started looking into workers, so web workers have been a big help. That's really helped with performance. Recently, I started working with WebGL, which means that I can be running everything on a 3D context instead of a 2D context, which means automatically on a lot of hardware it will be on the GPU instead of the CPU, so that's been pretty cool. I also have been doing some stuff for this Codevember, because it's November. So if you want to check out my CodePen, there's a whole bunch of audio visualizations based on the generativeartistry.com, which is a website that Tim Holman put up at the beginning of this year. And it just goes through, if you just want to do some creative coding, you can just go through and do some of his tutorials. And it just does some really nice generative art tutorials. I've got 40 seconds, according to that timer. I want to address one last thing before I go, right? This. See, I think this was a useful talk. For the keen-eyed among you, you might have noticed the whole portable VJ pack held together with duct tape. I've lost audio again. This kind of sucks. I'm going to turn it all the way up. OK. Yeah, the portable VJ pack held together with duct tape. Ben is on a bike, right? This whole function is a workaround. And I'm drinking coffee. Most useful talk ever. Thank you very much. My name is Ruth. You can find me at @Remira. Come and talk to me after you want to talk about any of this. The music in this is by a girl called at Kanoa. She's based in London. Check her out on SoundCloud. Thank you very much.